Hi, I'm Kevin Hauser. I'm the author of a new book. It's called The Unauthorized Ubiquiti Radio and Access Point Handbook. There it is. It's actually a large print book, large style book, because we got a lot of graphics in here. So why did I do this book? Well, let's talk about me, because I like talking about me. I'm a full-time Ubiquiti trainer. I traveled the country doing wireless classes and routing classes, and I've been to a lot of wireless classes, and I see some of the same questions, some of the same concerns, some of the same people will have the same kind of concerns about what's going on in their network and why am I having problems? Why am I having X problems? We tend to spend some time in class looking at people's radios, or remoting into radios, or remoting into access points, or looking at Unify and finding out what's best for them. Well, a lot of people in this world, Unify is a beautiful thing, and AirOS is a beautiful thing. Super easy to set up, really easy. I'm sure a lot of you have watched, 20-minute YouTube videos and went step by step configuring Unify or configuring an outdoor radio and thought, well, this is easy. When you take that configuration and you start putting it in a more commercial environment, a restaurant, hotel, you start having more problems, and it's hard to understand why am I having these problems. So the book does a much deeper dive into things like physics and troubleshooting to tell us why we're having problems. Okay, so with every single video that I'm going to do in this series, I think there's going to be 10 of them. This is number 1. In this series, what I want to do is kind of take that deeper dive and walk you into the book. Why am I doing that? Well, not everybody can take 2 days off from work to take a class, and they're not really that inexpensive. They're quite expensive taking a class. So not everybody can do that, but everybody can, get a $45 copy of the book. They can do that. So everything in this book is stuff that we go over in class. Everything in here and more talks about, problems that you might have, or configuration problems that you might have, or why am I having X problem? So today, in this video, we're going to look at 2 things. The first part, we're going to actually do a short troubleshooting segment. And the second part, we're going to look at noise and how that affects wireless. And I've chosen noise because it affects both indoor wireless in the world of Unify and outdoor wireless in AirOS. So, like I said, with every video, we're going to have a little troubleshooting tutorial, and we're going to have more granular deep dive into things like noise, and etc. So this first part is going to be the troubleshooting part. So let's get started on that. To do that, I'm going to grab an access point. Give me a second. All right. Here we go. So I have your basic Ubiquiti Unify access point. This is a NEC light. In the world of troubleshooting, let's start with some real basics. Oftentimes I get the very first question right out of the box is, how come I can't adopt this device? I'm having trouble adopting the device, or I can see the device in my controller, but when I try to adopt it, I can't get anywhere. And that's really super frustrating. Or it never shows up in my controller in the first place. All right, so let's talk about some major steps that you're going to have to walk into. Okay, so step number 1, and this is in the book in the troubleshooting chapter, is the device in an adoptable state? Okay, so what that means is, and you can kind of see, I'm in a sunny environment, but I can see the little white light here. This white light is constant. This is in a default state. If this light was blue, it would mean it was adopted by another controller previously. If it was cycling between blue and white, it could be in a provisioning loop. It could be doing some other weird stuff. So make sure you have a solid white light. So that's step number 1. Step number 2, right? Step number 2 is it on a live network? Can it receive an IP address? Can it see a gateway? Can it does it have a subnet? If the Unify device isn't really on a live network, then Unify Discovery doesn't seem to work very well, and your controller will have a difficult time adopting that device. So when somebody sets up like a test environment, they wonder, why can't I adopt my device in a test environment? So even when we do the classes, we make sure we have live internet so we can get everybody's device adopted. Now, another thing that could possibly happen, and this has happened in the past, is the version of your Unify controller, the software controller that actually manages these devices, might be super, super new, but the firmware on this device might not be. Okay, so if this firmware on this device is older than 4.0, for instance, your controller might see it and give you a choice to adopt this device, and it will never adopt. So how do you get around that? Okay, so there's a couple ways. Way number one is actually my way, because it's kind of the lazy way. I have a controller in class that I have on a cloud key. So I run the class off of a cloud key, which is basically like a big self-contained flash drive that holds all the software for the controller. I also have a controller on my laptop loaded locally, but it's a much older version of the controller. What I will normally do is start my laptop controller up, right, which has an older version, and that older version will have a much easier time adopting this access point because the firmware update for this device is actually embedded in the controller. All right, so a newer controller might not be able to, like I said, sense this device or talk to it. So using an older version of the controller most times actually will work. Now, I just do it because I already have a version loaded on my laptop locally, so it's not a huge deal, right? Another way to do it would be to putty into this device, right, using SSH, and you can run a command to run the upgrade if you have the file locally on your PC. So those two methods will probably get this thing adopted. And like I said, it's not unusual for people to have that problem. Generally, what I find is not in an adoptable state. It's been previously adopted, or it's got stuck in some weird provisioning loop. Just reset it. Push the reset button down for 10 seconds, let it go. If it's on a live network, you're all good. So that's my troubleshooting tip for how come I can't adopt this darn access point. I know it can be really super frustrating. So trust me, I've been there. I know what you're talking about. All right. So the next portion. All right. So the next portion of this, we're going to talk about noise. Okay. So I'm going to show you some noise. I actually have a radio set up. So I'm going to give you sort of a noise overview. So bear with me. We're going to get that done. Hold on. All right, very good. So I've actually opened with a simple slide that I made, noise and interference. We're going to talk about noise and interference, and I'm going to show you in graphic detail what this actually involves. I always go over this first in my classes because it seems that a lot of people are familiar with some forms of interference or some forms of noise, but they just don't really have the entire thing down pat yet. So this is kind of why I'm going to go over this. So the first part is like, what kind of noise do we have? Like what's our level what's our level of noise, that we're going to deal with, right? So the first level is something called thermal noise. And of course you can read the description. Creation of a radio wave in a circuit makes thermal noise or creates thermal noise. This is also known as Johnson noise or Johnson-Nyquist noise or just Nyquist noise. They've known about this for a long time. So when a radio is creating a radio wave, within that circuit, there is a byproduct of noise. These free electrons rubbing together make noise. And this happens no matter what the output power level is. It's just there all the time. Okay? So because it's there all the time, it's hard to quantify. All right? So we can see it or quantify it using a simple $50 radio. So that's what I'm going to do now. So bear with me. I'm going to actually open up a radio. All right, let's do that. All right, very good. So what I've got here is I've got a NanoStation 5 AC Loco that I use for testing, and it's not currently in a point-to-point mode or point-to-multipoint mode. It's just sort of hanging out on my desk. And the reason I'm using this radio, and this is the $50 radio I mentioned before, is I just want to look at the tools. So inside the tools menu, I want to run AirView. AirView is a really nice tool in AirOS to show me, well, it's got a spectrum analyzer. If you were to buy a Unify HD access point, it has AirView built into it. So rather than have a $350 access point, I have a $50 radio. Now again, radios are super, super sensitive. They can sense very small noise levels, very small signal levels. They are extremely sensitive, and that's a good thing, that they can sense small signal levels. They can also sense noise, and maybe that's not always a good thing either. All right, so let's look at this screen. So the first screen at the top shows waveform view. Okay, so waveform view is basically showing us these little white peaks that are running up and down. Those are data frames that this radio senses moving around. The higher off the baseline they are, the more signal it's detecting. And this particular radio isn't really aimed in any particular direction, by the way. The orange part that you can see, or the orangish reddish part you can see at the bottom, is more intense noise. this is really representing our noise floor. Okay, so that's actually pretty neat. So we can see that the orange portion resides around -110, usually between -100 and -110, and that's kind of normal. Again, I live out in the middle of nowhere where there's not a lot of radio waves, there's not a lot of anything out here. So this for me is pretty normal. Okay, so the radio intentionally will actually add to this floor with a reading called CINR, or Combined Interference Noise Ratio. So interference will actually get added to this noise floor to be computed against how well our signal's doing. All right, so I mentioned earlier that the transmission of data or the reception of data actually makes noise. And you can kind of see this in a little bit here. Around 5200, there's actually a channel nearby on this frequency. And what's going to happen is the more data frames that this thing sees on that frequency, this orange floor will actually peak up right there. You can actually see the orange floor get taller right there where it's actually sensing more data moving. So the movement of data makes noise. So this is actually a pretty neat screen to be able to look at and see what's going on here. So like I said, I don't really have a lot of radios running, so you can see this is a pretty clean environment. The next screen down is waterfall view, and this is more of a time-lapse view. And you're sort of looking at the depth of the richness of the deeper colors, like the blue. This is showing very little noise. And then when you start to see colors like, you know, the darker greens, the orange, all the way into red, these are higher levels of noise. You can kind of see that scale here on the right-hand side. Now, the bottom part of the screen, right, you can kind of see that I've created this big mess earlier. I was running my mixer, my wearing blender, and we'll talk about that in a second, but you can see up here between 315 and 320, I was mixing potatoes. So this is a EMI, a form of EMI, and we'll see that in a minute, but this is actually showing more in-depth noise, and again, I can hover over it and see kind of where it's at. Right now, we're not running the blender, so we don't really have that noise problem. So anyway, that's where I was running my little blender, okay? So this is actually a really cool little tool to be able to use to sort of get an idea of what's currently going on in your environment, right? So if you have an HD access point, you can see this tool called AirView, or you can use an inexpensive radio, or even an expensive radio, and you could run AirView, right? So this is very helpful in showing us what's our baseline noise, what are we trying to overcome, all right? So that's actually pretty neat. All right. All right, so this next part, we're going to look at in-band interference. So in-band interference is when a radio nearby another radio is going to be interfered by that other radio. In other words, they're on the same channel or the same frequency or a close enough frequency to interfere with one of those radios. And then what actually interfere with both of those radios? That's the net effect. That's actually what would happen. So in-band interference is prevalent indoors when access points are too close to each other on the same frequency, and it can happen outdoors if you're on a shared tower space with another vendor and he has changed his frequencies and you have not. So this becomes an issue, okay? So one of the things we can do outdoors would be to use air prism, which will help our radios filter out that unnecessary noise. And indoors, we just have to do really good channel planning assignment. If we don't do really good channel planning assignment, we're going to have trouble. So that's one of the main things. All right, so third, RX, I mentioned this before, so receive energy. When a radio receives a signal, this actually makes noise. When the radio is moving data in and out, there is noise that's created. If the radio is operating on a large channel, there'll be more noise, let's say on an 80 megahertz channel, than on a 20 megahertz channel. So be aware of the movement of data, and we saw that in the AirView as well. Movement of data will actually make noise. So this is something you have to be aware of. The reason we have to be aware of that is because it's generally the channel size that's going to get us in trouble. The issue of channel size is simple. Larger channels will move more data. Larger channels will provide us more throughput, but the drawback is that we will actually have more noise included in that channel. And larger channels will actually go less distance. So on an outdoor radio that has a long distance connection, it's not going to go as far as it would on a smaller channel. So RX noise is prevalent. Okay, so that's something we also have to to think about. Again, this is not the same as interference. This is a known quantity. This is a known thing. All right, so this is something that we already are aware of. Very good. Now, the last flavor of noise is EMI, electromagnetic interference. I was startled when I read a post on some online social media where somebody says, I was surprised that a microwave oven will interfere with my Wi-Fi. Well, yes, it will. And it's not just a microwave oven that'll do it. It could be other things like motors. It could be the television. It could be audio equipment, video equipment. A lot of these things will create noise. These are known as non-intentional radiators because they're making noise even though they're not supposed to make noise, right? And they weren't built to make that noise. That's true. So how do we solve this? Well, obviously, if you're trying to avoid microwaves, you don't want to hang an access point near a microwave oven or near an electric motor. The further away from these things, the better. Outdoor radios can be shielded. You can actually use a form of shielding to stop radio waves from striking the radio from other radios. So distance and shielding, these are two basic things that we actually will actually see. EMI can be more destructive than many people realize, and it could come from sources that people don't often recognize. All right, so I'm going to show you what I'm talking about. Okay, so I wanted to demonstrate EMI, and I was thinking of different ways to try to do that. Rather than hold my radio up near a microwave oven, I have something that I just got at a yard sale. This is probably a 60-year-old wearing blender, right? So it's lovely, right? And I remember these things from when I was younger, being at the mother-in-law's. She's up there using a blender to blend mashed potatoes or something, and the television no longer works. So what I'm going to do, right, is I'm going to pause the video, and I'm going to hold this near the radio, actually in the vicinity of the radio, and we're going to let it accumulate some of this noise signature and see what it does in that bottom view, or the ambient noise level, and see how it affects that. All right, we'll be able to see that. So that'll actually be kind of neat. All right, so let's do that. Now that I have the blender off, you'll actually see that, give it another minute or so, you'll actually see the blue and the lighter colors come back, and the more red and angry yellow colors will disappear. But this is the nature of EMI. This is the nature of noise. So it doesn't always have to be something that will operate on a particular channel. In other words, a microwave oven doesn't operate just on channel 1 or just on channel 6. It operates across that spectrum and can cause interference on multiple channels. So you can't really hide from this type of interference by channel selection. What we can do is try to avoid these types of noise, or avoid this type of non-intentional radiator. Now, when I consult on hotels, there are many sources of non-intentional radiators. This could be an elevator motor. It could be swimming pool pumps that actually moves the water for a swimming pool. These types of things make lots of ambient noise. They create lots of noise. So trying to shield yourself is the best way. Avoiding that particular frequency doesn't always work. Okay, and we can actually see that here in AirView. I'm going to go back up to the top, and you can see it's starting to get nice and clean down at the bottom again. So we're back in business. All right, cool, very good. So let me close this part out, and we'll go back to the video. Okay, so this wasn't super long, but I'm hoping that you took something away from it. Noise, interference, they're not always the same thing. People like to throw them together in one sentence, but they're not always the same thing. Interference, like I said, is generally sporadic, sort of like our electric mixer. Things that happen quickly and are hard to spot, hard to replicate, that's interference. Noise is generally a background that we have to overcome based on where the radio actually is. Now remember, these radios are extremely sensitive, right? They can hear very minute bits of noise. They can hear very minute signals. So you get the good with the bad. It's good that they can hear very minute signals. It's not so good that they can hear noise. So that's just inherent in the nature of the radio. It doesn't really matter what kind of radio. They're all very sensitive, and they will hear noise. So if you understand that it exists, that's a good step in the right direction. And like I said, we can do certain things to sort of lessen its damage. We can shield our radios. We can try to place our APs more distant from noise sources. We can use smaller channels. We can use lower power, so we don't actually make our cells too large that we pick up all this extra noise. So there's a lot of little things that we can do, and I think what we looked at is a good step, a good starting point. So I hope you enjoyed this video. The next one should go into more deep dives on fun stuff, including troubleshooting. So thanks for watching. I appreciate it.